Welcome to Ritnova Solutions Inc., a business object solution provider and education partner. In today's presentation, we're going to see how to denormalize database and what are the effects of normalization or denormalization of a database. Also, later on, we'll build the same dimension or set of dimensions using data integrator to demonstrate the power of DI. In this presentation, I will use Island Resort Marketing's database, which comes with the business objects installation, the sample database, which is called club.mdb in Microsoft Access. So currently, I've migrated this data to SQL Server, and the three tables which I want to denormalize are these three. As you can see, these tables have been denormalized to the highest level, which means in each table only one column is of use for reporting purposes, and other columns are either primary key or foreign keys. Like here you see region ID or city ID, or in this table you see region ID or country ID, and in country table you have country ID. So the only column which will produce data for us is country, region in region table, or city table, city column in city table. So let's combine these three tables, or let's denormalize these three tables to take away joins to make our query faster. As we all know, joins or where clauses are overheads on the database engine, because when you have more than one table, then each row of one table is compared to each row of other table, which is also called Cartesian product, and then using where clause, unwanted rows are chopped off, and then the result is produced. So if you have 1 million row in country table and a million row in this table, then you can multiply 1 million by 1 million, and those many comparisons will take place, which will consume a lot of processing time from the server. So here, let's take this query. Let's denormalize here using the plain SQL query. Actually, I had created a geography dimension. Here I'll create jog dimension. So what I'm doing here is I'm selecting 4 columns from these 3 tables. I'm using these 2 joins, and I'm saying copy the result into this table, dim geography jog. So if I execute this query by pressing F5, this table will be created. Let's press F5, and it says dim geography because it is a table. If I press again, there's already dim jog. So let me create dim geo, and it says 49 rows have been affected, meaning copied into the new table. So you see all 3 dimensions are there. In my previous presentation I had created geography, then jog is there, and I have geo now. Let's take a look at the data of the dimension denormalized 1 table from 3 tables. So if I click on insert tables and press refresh, you'll see the geography is there, geo and jog. So I can take either of the table. I'm selecting geography, and which was created previously, or to avoid confusion I'll choose geo, which is this one. If I right click and say show me table values, it shows me one table which contains country, region, city. You must have heard a term called redundancy or repetition, which you can see Japan is repeating so many times, Australia, Germany, Holland, UK. So please bear in mind, redundancy does not mean duplicate. Redundancy means partial values of a table will be repeating. Like here, city and city ID are the most uh, deepest level of granularity, or level 0 in this table, city and city ID, which will not repeat. But then region and country, which is the partial table, the two columns of the table, are repeated. So after denormalizing, because joins are taken away, query becomes faster, as we know joins are overheads on the database engine. If I say show me list of the table values from country table, as you see here, it is listing each country once only. Let's say I want to change UK and US to United States of America and UK to United Kingdom. Only 2 updates are required, because normalized databases are meant for writing purposes. In shorter time I will update successfully the 2 names of the countries. But if I have to update in denormalized database, then I will have to replace UK 1, 2, 3, 4, 5, 6, 7, 8, 9, and US is appearing 10 times, by United States of America, and UK by United Kingdom. So you can see pros and cons of norm and denorm kind of databases. Here we have successfully demonstrated combining city, region and country tables into one table, which is the DimGeo. I can now link my city ID to this city ID, and if my universe queries using this dimension, results will be much faster compared to these 3 tables. The final star schema which we want to build is this one, where we have built with a T successfully the dim geography dimension here. So that's about it. This is Shabir Khan from Ritnova Inc. presenting building star schema. Thank you so much, and we'll see you in the next session.